Okay, so today we want to start talking about just polynomials. Remember, those are just going to be a number times some multiples and then a bunch of them added together. Right? You have all these terms made up. Things that make a polynomial is all the powers are going to be positive whole numbers. Right? So your powers are going to be first power, second power, third power, fourth power. You're not going to have any rational exponents. You're not going to have any negative exponents. So that's what we're looking with polynomials. But here's kind of the weird, kind of general form we have. And with this, if you notice, we have A, and this is a subscript of n. So like shifted down. Read that as A sub n. This is what's called the leading coefficient. That's just the number in front of the biggest power part. Okay, so. And then x to the nth is just, of course, x is our variable, and n is just some power that it's to. So it's raised to, so that's a fifth power. This would be in standard form. A polynomial is in standard form if you go from highest exponent to lowest. Okay, so you'd have your biggest power is x to the sixth. Whatever has x to the sixth comes first, and then x to the fifth, and then x to the fourth. And we just go down from there. And so just some things that we get is, again, so if you have this polynomial, so n would be our biggest power, correct? It's in standard form. So we would say that the degree of the polynomial would be n. And we'll look at an example where maybe this will match up a little better in just a second here. Just kind of get this. The leading coefficient. Now, coefficient just means the number part in front of the x part. Okay, so that the leading coefficient would be A sub n, because that's going to represent the number in front of the biggest power of x. So if the biggest power is x to the sixth, then there's a 3 in front of it. 3 would be our leading coefficient. Ends up being important later on. We talk about that. So we talked about standard form, degree of the polynomial, leading coefficient. Hopefully you remember things like a one-term polynomial. It's called a monomial. If it's got 2 terms, it's a binomial. 3 would be a trinomial. Those are some terms that you should recall from algebra. If it has like 4 terms, we just say it's a 4-term polynomial. I mean, we could find words for it. If some other words that we come up with are in terms of degree. If the degree is 1, we say it's linear. Right, so if you have a polynomial, so for example, that would be something like 3x plus 2. Right? We see 3x plus 2 is in standard form. The biggest power is x to the first, which makes it linear. Our leading coefficient there would be 3. Constant term, which is the one with no variable, that would be 2. Those kinds of things. If it's degree 2, we have a quadratic. So for example, if you had negative 7x squared plus 13, right? Now this is a quadratic because its biggest degree is 2. There are 2 terms, so it's also a binomial. You say it's a quadratic binomial. If you want to use all your big fancy words there. And the leading coefficient here would be negative 7. Right? That's the number in front of the x squared. The constant term would be 13. I guess I could write that up here. The constant term is going to be A sub 0, which is that has no exponent on it. Degree 3 is cubic. Right, so you could have something like 2x cubed minus 7x squared plus 3x minus 10. So we can see we have 4 terms. But the term with the biggest power is this 2x cubed. So in this case, our degree is 3, so it's a cubic. Leading coefficient is 2. Constant term is negative 10. Okay, so once we know kind of how to name things and what standard form are, some of our basic operations with polynomials are just to add and subtract and to multiply those together. So we want to review that. So for example 1, we want to simplify and put into standard form. I know just from quizzes and tests and looking at problems students worked out in the past, just it's really important as you look at the problem to realize what operation you're performing. Okay, here, this parenthesis indicating we have this 3-term polynomial, right? This trinomial, and then we're subtracting another trinomial. So this is a subtraction problem. A lot of students will get it wrong and waste a lot of time by trying to multiply things that aren't asked to be multiplied, right? Because addition or subtraction are really pretty easy in terms of working with polynomials. So what we're going to do is, because we know that we're subtracting this whole trinomial here, this 2x squared plus 4x minus 12, what I'm going to do is my first step is just to get rid of the parentheses. Then I'm going to go through and collect like terms, right? We talked a little bit about like terms with radicals, but remember with exponents, they just have the same letter with the same variables on them. So here, there's no negative in front of this parenthesis, and there's no number touching it, so the parenthesis really doesn't do anything. We just distribute a 1. 4x cubed plus 3x minus 5. Here, we're subtracting this. Students tend to miss this problem because they forget to distribute the negative, right? Because you have to distribute that. So we get minus 2x squared minus 4x and then plus 12. Right? That negative is going to hit each piece. So our goal now is we just have these 6 terms. We're going to find ones that match, and we're going to get our answer here. So in order to write in standard form, I'd look for the biggest power first. Well, I see an x cubed. That's the biggest power. So we'd say 4x cubed. I would encourage, a lot of people will cross stuff off, which it works if it works, but if you have to go back and check and you've crossed a bunch of stuff off, it can be confusing. So what I like to do is just underline things as I use them. That way, if I need to go back, I can make some other mark to kind of keep track of things. So here I had 1 cubic, right, x cubed, so I put that. Here's an x squared, so let's say negative 2x squared, right, the sign before it goes with it. Here I'm going to look for x's. I have a 3x and a minus 4x. Add those together to get negative x. And then negative 5 plus 12 gives us plus 7. So we end up with this 4-term polynomial, right? It's a cubic, right? It has 4 terms. Our leading coefficient, a sub n, would be 4. Our degree, which we would say n, would be 3, right? Because the biggest power we see is a 3, so it's a cubic, right? The number in front of the x cubed is a 4, so that's going to be our leading coefficient. Our constant term, which you might call a sub 0. Here, this is the leading coefficient, again, which we call a sub n, is 4. And then our constant term is going to be 4. I'm sorry, the constant term is going to be 12. Down here. But just to, you know, and this would be the degree. So really, a lot of times you want to know the degree, what's the leading coefficient, what's the constant term. That's kind of the big 3 pieces we look at. Any questions with that? So now a couple addition problems. I will show you a couple different ways to do them. This is just a binomial times a binomial. You might remember this is your FOIL property, right? First, outside, inside, last. I always just think of it as that I know that each term of this first parenthesis has to get multiplied by each term of the second parenthesis. Okay? Whether it's a binomial times a binomial or a trinomial times a trinomial, that's what we're looking at. Right, is each term of the first has to get multiplied by each term of the second. Now, if you have 3 parentheses, which you'll see sometimes. You got to get an answer for multiplying two of them together, get that in standard form, then just do the process to the next one. So with this, so really what we're doing is, and I normally don't show this step, but I'm going to do 2x times 6x plus 7, and then plus 3 times 6x plus 7. If you're having trouble and you don't like FOIL, that's fine. Then from here we'll distribute the 2x, so 12x squared plus 14x plus 18x plus 21. If we look, we do have like terms here, so that's going to give us 12x squared plus 32x plus 21. So if you needed to kind of break this down here, this would be a cubic, because it's degree 3, trinomial, because it has 3 terms. Okay, its degree would be 2, because that's the biggest power. The leading coefficient would be 12, because that's the constant in front of the highest power of x. And the constant term would be 21. Everybody good there? Okay. Now, I kind of always do them like that. I'm okay just working down the page. It's not a big deal for me. The textbook kind of recommended another technique that may appeal to you. Doesn't to me as much. But here we have a trinomial times a trinomial. Oh, yes?
Why is it cubic trinomial and not quadratic?
Because it is quadratic, and I just, hello Monday. Yeah, thank you very much. This is actually a quadratic trinomial. Sorry, everybody. That was just wrong. Yeah, thank you. But yeah, that's just a quadratic trinomial. But now what you might notice is here you had a binomial times a binomial, right? 2 terms times 2 terms, and we ended up with 4 terms before we simplified. So like here, I know if I have a trinomial times a trinomial, 3 terms times 3 terms, if we multiply those, we're going to get 9 terms, correct? So it just kind of gets to where organizing things can get to be a headache. But if you just write it out, like you could do an idea like this, you could do x squared times this plus negative 4x times this. You could do that. You could kind of just work through it however you like. The textbook kind of recommended this vertical method. I thought I would try it. And it's just like how we used to write things vertically, right? Is you can kind of do it like this. What we'll try to do is try to group things in columns based upon degree. So let's kind of see what happens here. So first, let's take this x squared and multiply it by each piece at the top. Right? So x squared times x squared is x to the 4th. And then x squared times negative 4x is negative 4x cubed. And then x squared times 3 is plus 3x squared. Seem believable so far? So again, I just did x squared times each of those pieces. Now let's do the 4x times each of these. But here, when we do 4x times x squared, we're going to get 4x cubed, correct? So let's just go ahead and make our lives easier and put it underneath this one. We'll keep all the x cubes together. Interesting. Again, not anything I usually do, but so we get 4x cubed, it's going to be positive, and then minus 16x squared, and then plus 12x, and then now we'll take 5 times each of these. So 5x squared minus 20x plus 15, and then if we just add all those parts down, it should give us a nice standard form equation here. So it should give us x to the 4th and so these will cancel. This will be 8x squared minus 16, so that's minus 8x squared minus 8x plus 15. That's what we get. a fourth degree polynomial with 4 terms. Right, notice the cubic term's missing, so we use, if you needed to write the coefficient, like if you're doing synthetic division, remember you put a 0 there for it, but we don't put it there. Yes?
Can you do the box method instead for this problem? Like I did the box method and got the same answer.
If you like the, yes, the question is, can you do the box method? If you, whatever works at this point, you just gotta be able to multiply them out. I don't really use boxes because they just, you know, they're not my thing, but yes, they're perfect. So yeah, as long as you can get the answer, we're good, right, by hand. There's just another option there. Okay, kind of to wrap up our multiplying polynomials, we talked about addition and multiplying, subtracting, but for multiplication, there are some products that come up a lot that if you just know the pattern, you can save yourself a lot of time. You know, the more time you save, the more complicated the pattern might be, but it can be really helpful. This one you might recognize as just the difference of 2 squares, right? Maybe you saw it as a plus b, a minus b, but whenever you multiply what they're called conjugates, is what they're actually called, of that form, you'll just get u squared minus b squared. So we use that a bunch in trying to eliminate different, maybe degree 1 terms and things like that. But again, you could prove that if you wanted to. You just would do u plus b, u minus b. We could FOIL it or distribute, however you want to do it. So if you did u times u minus b plus v times u minus b. Again, I put big legs on my u's so I can see them. Here's u squared minus uv plus uv minus v squared. And notice here, even though I did v times u, I still wrote it as uv. If you kind of keep things alphabetical, you tend to notice those patterns. And then we're just going to get u squared minus v squared. Just the difference of 2 squares pattern. Okay, the other one's here. So this one is just, we could look at an example of that, would be something like 3x plus 2 squared. Now, could you write, if you wanted to just work this out, you'd have to write 3x plus 2 times 3x plus 2 and FOIL it, or use properties. It's wrong to just bring the squared inside. That's not any property we will ever see because that plus is in there. It keeps that from happening. But what our pattern tells us is you take the first term, so that's the 3x, and you square it. And then you do 2 times the first term times the second term. Then you do the second term squared. So that would give us, remember, square both pieces, 9x squared plus 12x plus 4. I really think the best reason to really get to know this form, really to understand it, is that when we go to factor it, whenever you see one like this where you have a 9 and a 4, which are both perfect squares, there's a really good chance it's going to factor back to look like that. That's kind of what's going on there. These on the bottom might look they are kind of strange. If you could just remember the 1, 3, 3, 1 as far as the coefficients, and then notice that it's u cubed, u squared, u to the first, there's no u at all. And then here we go v cubed, v squared, v, no v at all. This one's the same, except here you could kind of think of v as being negative. Well, if v were a negative number, if there's no v at all, the term would stay positive. If there's a single v, it would make it negative. If there's 2 v's, or v squared, the negatives would cancel out and make it positive. And if there's 3 v's, the negative would be preserved. So that's kind of what's going on there with the signs. So an example of that would be something like, here's 2x minus 3y cubed. All right, so we would use this property here. Okay, and again, I'm just going to remember we're going to take the first term and we're going to cube it. So that's 2x cubed. Now, I'm going to have a single v in this second term, so I'm going to make it minus. And then there's the 3 from the formula. There's 2x squared. And there's 3y. That's a big parenthesis there. I would leave my 3y. It's up to you. You could make all your 3y's negative and then make these all pluses. or you could follow the pattern. You just have to kind of account for it one way or the other. The next one is plus 3, and it's going to be 2x times 3y squared, and then it's going to be minus 3y cubed. Okay. You write this out, it doesn't feel like it's saving you that much time, but you get quicker at them. So here, 2 cubed is 8, so 8x cubed. This will become 4, right? So 4 times 3 times 3, so 4 times 9 is 36. And then we get x squared y. Here we get 3 times 2 times 3 times 3. I know that 3 times 3 times 3 is 27, times 2 is 54. Xy squared. And then here's this 3 cubed, we said was 27, so minus 27y cubed. We don't run into these a ton, but if you do have two variables, a lot of times your standard form is kind of the, because if you notice, if you think back, they're all degree 3 terms because they all have a third. They have 3 unknowns in them. Right? But usually you start with the one with the most x's and kind of decrease and go down that way. Okay. So, but again, I would encourage you on the book work tonight, there's some special products practice that you want to look